Welcome back, guys. Welcome back to 5-Minute Math, man. Welcome back to erbsclass, and welcome back to derivatives. Yeah. So today we're going to talk about how we use derivatives to find maximums and minimums. Yeah, maximums and minimums. You can lump them both into one word called extrema. That's some fancy calculus talk. But let's get a function up here in a picture so we can get more of an idea of what we're talking about. Okay, yeah, looks good to me, but a picture will probably help us out. Now, you won't always have a picture, but it's going to help us learn. So let's get a picture of this function up here. Yeah, so my function looks something like that, generally speaking, right? So notice there's a high point in the graph right here, and there's a low point in the graph right here. That's what we mean by maxes and mins. So sometimes in a lot of different applications, it'd be real sweet to know where these happen, right? The spots where I hit a high and the spots where I hit a low. Now remember what that tangent line looks like. The tangent line at these spots, remember, is horizontal. Remember, the slope of the tangent line is the derivative. What's the slope of a horizontal line? 0. Yeah, that starts this whole lesson. Yes, let's get it down now. That part, let me read it to you. The x values for the maximum and minimums are at the x values where the derivative, which is usually an equation, equals 0. Now, it's going to probably take you some solving to solve this derivative equation for x when it's equal to 0, but those x values that you get out, those are the x values that those max and mins occur at. Yeah, these x values, those x values. And now, if you want to know the actual height or the actual coordinates, then we take those x values and we plug it back into the original equation. Let's write that down too. I'll say it one more time. To get the actual coordinates, if I wanted to know the coordinates of that point, I would take those x values and plug them back into the original equation. Yeah, let's do an example so you know what I'm talking about. Let's use this one right here. Okay, fresh boy. Now, if I want to know where the max and mins are, either one, too. As soon as you see maximum or minimum on a problem, sometimes they'll have one, sometimes they'll have both. As soon as you read that word, max and min, think this. Derivative equation equals 0. If that's my original equation, I need the derivative equation. That's a polynomial, that's power rule. We know how to do that from the other video. Yeah, there's my derivative equation. If I want to max and min, what do I set that derivative equation equal to? 0. Yes, and now I solve. Now, the way that you solve this equation is going to vary depending on what kind of equation you have here. But the moral of the story is the same. You set the derivative equation equal to 0 to find the maxes and mins. So now let's solve this, man. It's a quadratic. I know how to solve quadratics. Factor, you can use the quadratic formula, you can graph it on your calculator, but I know how to factor. GCF first, of course, and then I factor. Yeah, of course, and then I set the factors equal to 0, which gives me the roots. If you need some refresher on factoring, there's a video for that. At these x values are where I will see a max or a min. Yeah, let's go over here to the graph and check it out. At x equals -2. That's got to be this one right here. Look at that. Yeah. So if that's x equals -2, doesn't the other one have to be 4? Yes. Now, sometimes just the x values is not enough. What if I need to know the actual coordinates of that maximum? I take that x value and I plug it into the original. This equation right here, when I plug it in, it's going to look like, yeah. So if I want to know the coordinates of this point, I take the x value I know of -2 and plug it into the original. Looks like this. Comes out like this. 58. When I plug in -2, I get out 58. Those are my coordinates to the point. That point right there. And now I do the same thing for the other x value. X equals 4. Yes, just like that. When I plug in a 4, the original function gives me -50. Those are coordinates. Over 4, down 50, that's my other point. Yes! Now you would have to do this if we didn't have this picture, if you wanted to know which one was the min, which one was the max. The maximum's got to be one with the higher y value. Yeah! Man, I hope this this helps, man. Thanks for coming back to check me out, man. If you need some more help, I got plenty more of these. I'll see y'all next time, man. Thanks for checking me out. Bye.